Life on extreme worlds, how organisms could adapt to fire and ice planets. Imagine a planet where oceans boil or one where the air is colder than liquid nitrogen. Could life still exist? Life on Earth thrives in narrow temperature ranges, but extremophiles, microbes that endure insane heat or freezing cold, prove that life is tougher than we think. If life can survive in volcanic vents or beneath Antarctica's ice sheets, what about entire planets locked in permanent firestorms or endless ice ages? Prepare for a journey into the strangest forms of evolution imaginable. 1. The firestorm worlds, planets where rocks melt. Picture a runaway greenhouse planet like Venus, but worse. Temperatures soar to 900 degrees Fahrenheit, 480 degrees Celsius, hot enough to melt lead. The air is thick with superheated carbon dioxide, and the surface pressure crushes anything that lands. Could anything survive here? Surprisingly, yes. Life adapts to any conditions if it has time. Silicon-based life forms. On Earth, life is built on carbon, but in extreme heat, silicon is a better choice. Unlike carbon, silicon remains stable at high temperatures, meaning an entire biosphere of rock-like creatures could exist. Metallic-skinned organisms. To withstand radiation and heat, life might evolve metallic exoskeletons, possibly using iron, titanium, or even reflective gold-like coatings to deflect heat. Plasma-based microbes. What if life isn't made of molecules at all? Some physicists speculate about plasma-based life, organisms that form inside intense electrical storms using charged particles to store information and reproduce via electrical currents. Would you dare step onto a world where the ground is lava and life itself is metallic or electric? Drop your thoughts in the comments. 2. Ice worlds, planets colder than Antarctica. Now let's go to the other extreme, a frozen world locked in an eternal winter. Think Pluto, Europa, or rogue planets drifting through space with no sun. The surface is frozen solid, but deep below the ice, could something be swimming? Here's how life could adapt. Antifreeze blood. Just like Arctic fish use glycoproteins to stop ice crystals from forming in their blood, extreme cold-adapted creatures might evolve liquid antifreeze circulating through their veins. Slow-motion life, metabolism slows in freezing conditions. On a -300 degrees Fahrenheit, -184 degrees Celsius world, life might evolve to think in years rather than seconds, meaning a single thought could take a century. Ice shell organisms. Instead of skin, creatures could develop ice shells, absorbing heat from deep hydrothermal vents while using thick, frozen armor to block radiation. Could frozen planets harbor life that thinks slower but lives for millennia? Let's hear your theories in the comments. 3. The oxygen problem. Breathing on hellish worlds. Every living thing on Earth relies on oxygen, but what if a planet has none? What if its atmosphere is sulfur, ammonia, or pure hydrogen? Life might evolve radically different ways to breathe it. Sulfur-breathing organisms. Some bacteria on Earth already breathe sulfur instead of oxygen, living in volcanic vents. On a toxic exoplanet, this could scale up into sulfur-consuming megafauna, exhaling yellow, rotten egg fumes instead of carbon dioxide. Ammonia-based blood. Some alien creatures might use ammonia instead of water in their cells, meaning their biology operates at insanely low temperatures. These creatures could be purple, crystalline, or even glow in the dark due to chemical reactions inside their tissues. Hydrogen-based giants. Planets with thick hydrogen atmospheres could allow levitating life forms, floating like giant balloon animals, sucking hydrogen for energy while drifting in endless skies. What's the weirdest way you can imagine life breathing? Comment below. 4. Eyes, ears, and senses. How alien life might see the world. Sight is a human bias. On extreme planets, sight might be useless, so how would creatures sense their surroundings? Echnavigation. In dense atmospheres, creatures might navigate entirely by sound, using ultrasound waves like bats or dolphins. Imagine a blind predator seeing through walls with sound waves. Radiation perception. If a planet is drenched in cosmic radiation, life could evolve radiosensitive organs, allowing them to see X-rays or gamma waves. Some might even feed on radiation like plants use sunlight. Magnetic vision. On planets with strong magnetic fields, life might sense electromagnetic currents, effectively allowing them to detect invisible energy flows across entire landscapes. Would you want to see the world through radio waves, sound, or even magnetism? Tell us your pick in the comments. 5. Can life escape its home planet? Some scientists argue that life might not be limited to planets at all. Could alien life forms travel through space naturally? Spaceborne microbes. Some bacteria on Earth can survive in space. If they evolved further, could entire ecosystems of floating bacteria exist in the vacuum? Electromagnetic organisms. In deep space, life might evolve to feed off starlight or cosmic radiation, forming giant, jellyfish-like entities drifting between planets. Living moons. What if a moon itself was alive? Some exoplanets could host vast, organic landscapes where mountains are giant organisms and rivers are living liquid colonies. What's the strangest space life form you can imagine? Comment below with your wildest ideas. Final chapter, the future of life. Where are we headed? As we search the universe, one thing becomes clear: life adapts. It finds ways to survive in fire, ice, radiation, and even the vacuum of space. The question is not whether life exists elsewhere, it's how bizarre and extreme it can get. So now, I turn to you. Would you rather live on a fire planet or an ice world? What's the strangest life form you think could exist? Do you believe life can escape planets and survive in space itself? Hit like if you love speculative evolution, comment your wildest predictions, and subscribe for more mind-blowing content. This is not just speculation, this is the future of life in the universe.